In this tutorial, I'm going to show an advanced optimization technique called sets in Mason. Now here I've taken my standard Wilkinson design and I've added an extra little transmission line, and I'm going to use that to create a 90-degree difference between these two ports. So to accomplish this, I've set up 3 optimization steps: a genetic iteration, simplex run, and then a third simplex run. I've set up my figure of merits to have a set of 1 and 2. So the set goes through the numbered optimizations. So this is optimizer 1, optimizer 2, optimizer 3. So this figure of merit calculation will only be applied towards the first and the second optimizer. That's true for my match, for my through, and my isolation. Now I've set up another figure of merit calculation that's the argument of S21 versus S31. So this is the phase difference between these two ports. And this one I'm going to set up to belong only to set number 3, this third simplex, this third optimizer, the second simplex. Now I also need to group my variables. So my variables here I've also set up for sets. The Z1 and the theta 1 I have belonging to the first and second optimizer in the list, and I've put in an electrical length for this extra transmission line, and I need to update that in the impedance. So I'm going to allow this guy to optimize, but this is going to be fixed for the first 2 optimization steps, for the first gradient and the first simplex. This is going to be a fixed value, and it's only going to vary during the third optimizer. And these 2 are only going to vary during the first and second optimizer, and they're going to remain fixed for the third optimization. Now this Z2 parameter I've set up to be a variable. However, I've given it the no-opt tag here, so this is going to remain fixed no matter what. So I'm going to run Mason now. Now, if you were to try to run Mason and you used all of these different calculations of figure of merit and allowed all these variables to go at the same time, you would have poor results, because the optimizer would try to use this extra bit of transmission line to optimize your match and your isolation and your through characteristics, and all the parameters would be a little bit off. Instead, what I've come up with here is something that gives me the values you would expect. I'm falling within my expected 90 degrees. So here I have an old plot from a previous run, and I'm just going to copy the plots. Refresh. So if I pull up the plot, I can see that my Wilkinson is behaving well, and I can see that I'm at 90 degrees at 1 gigahertz, which is what I was designing for.